school is ready to begin. But there's 24 pranksters who decide to play a practical joke. Person number 1 comes by and he owns locker number 1. And instead of opening just his locker, he decides to open all 24 lockers. Here we go. There, they're all open. Person number 2 owns locker number 2, but instead of just closing his locker, he decides to close his locker and every second locker after that. There they are closed. Person number 3 comes by and instead of just closing his locker number 3, which is now open, he closes his locker number 3, opens locker number 6, closes locker number 9, opens locker number 12, closes locker number 15, etc. Person number 4 comes by and does a similar thing. So you can see that 4 and 8 are now closed, so he's going to open those, and 12 is open, so he's going to close that one, and 16 and 20 are both closed, so he's going to open those two. And you see the pattern that is kind of wild that's being produced. So you have to figure out, after all 24 persons have gone by, what's the pattern going to be like? Remember, the nth person who goes by is going to open or close locker number n, and every nth locker after that he's going to open or close, depending on whether it's closed or open. Okay, try it. Turn off the video. Try it. Tell me what the answer is. Maybe you need another hint before you turn off the video. Let's look at person number 5. They come through. They're going to close locker number 5 because it's now open. They're going to open locker number 10 and locker number 15 because they are now closed. And they're going to close locker number 20. Let's see that. If you haven't already turned off the video, turn it off now and solve the problem. I want to know what happens after all 24 people have gone through. Okay, let's now look at person number 6 going through. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All people have now gone through. A pattern has emerged. I'll leave it for you to figure out that pattern. Here's a hint. Let's look at the factors of each of these numbers. So what's the factors of 18? So, well, 1 would be a factor, and 2, because 2 divides into 18, and 3 also divides into 18. Is 4 a factor? No. 5, no. 6, yes. 7, no. 8, no. 9, yes. So there they all are. So we've got all of the factors here. Is this door 18, is it going to be open or closed after all these people go by? Well, person number 1 is going to be opening it. Then person number 2, because 18 is even, person number 2 is going to be closing it again. Person number 3 is going to be opening it again. Person number 6 is going to be closing it again. Person number 9 is going to be opening it again. And person number 18 is going to be closing it again. So it's going to end up closed at the end. So all of these lockers are going to be opened or closed at the end, depending on whether there's an odd or an even number of factors. Which type of numbers have an odd and which type of numbers have an even number of factors? I'll let you think about that for a while. Turn off the video, think about it, and come back. Let's look at 18, for example. 18 has an even number of factors. We can group them in pairs. 18 times 1 is 18, 9 times 2 is 18, and 3 times 6 is 18. Let's contrast that to a number with an odd number of factors. 1 times 16 is 16, 8 times 2 is 16, and in the middle, 4 times 4 is 16. All of the numbers with an odd number of factors are going to share this property. They're going to have one of these middle numbers. And you can see that those are square numbers. 3 times 3 is 9, 2 times 2 is 4, 1 times 1 is 1. And if I ask you to solve this problem for 1,000,000 people and to tell me, is the millionth locker going to be open or closed after all million have gone by, you're going to be able to say 1,000,000 is a square, it'll be open.